Should probably put like the forces. I think you should draw two diagrams like separately, the upwards one and the downwards one,
Okay.
because they're different, obviously.
So go on.
So for the one going upwards, that would be P, and then that would be F as well. Would be F. Wait, no, there wouldn't be friction because it isn't actually. Wait, I don't know. Would there be?
So this P, is it in this direction?
Yeah,
So
yeah.
okay. The coefficient of friction is mu when it is pushed by a force P directed upwards along a line that goes up. It is on the point of slipping upwards.
That means F equals mu R.
So F equals mu R.
So there would be a friction force. And then there would be R and mg.
So you have R and mg.
Mm-hmm.
Okay.
So it says express the coefficient. So then you could do mu is equal to F over R,
Okay.
and then you could find what they are, kind of. So if you resolve, um, like in the, I don't know what direction, but like in the R, like where R is,
Yeah.
then you would have R minus, um, mm, would it be mg? I'm not sure if it would be sine or cos theta.
Believe it's sine because it's opposite.
Oh yeah, okay. G sine theta. Yeah, that's it. It's equal to m. Wait, there's no a, so never mind. Is equal to 0. Therefore, r is equal to mg sine theta.
Okay.
And then, but f is just, wouldn't f just be equal? Oh no, it wouldn't. Okay. So p minus f minus mg cos theta is equal to 0. So then you could do f is equal to p minus mg cos theta.
Equals plus, is it? P plus? No, you're right. Minus
P minus mg cos theta.
cos theta.
So then in the mu equals f over r, you could just substitute what f is and what r is.
And so mu equals
Mg sine theta. Oh yeah, p minus mg cos theta over mg sine theta.
mg sine theta. You could change it, but I think that's okay.
Okay.
K and P. We're missing a. Sorry, K and theta. We're missing a K.
But the first, like when it's going upwards, there isn't any k, so
So now we have to do downwards, is it?
yeah.
Okay.
So the same thing like draw on the forces. So kp going down the slope and then f going up the slope. And then r and mg. I mean, it's basically the same method, like mu is equal to F over R, and then you what they are. So Kp plus mg cos theta minus F is equal to 0. So F is equal to Kp plus mg cos theta. Yeah. And then R is equal to mg sine theta. It's the same. And yeah, that's it. And just substitute back into, yeah. So Kp plus mg cos theta over mg sine theta.
Sine theta. We have a P. Were we supposed to have a P? I bet we weren't.
There was a P in the first one as well.
Yeah.
I don't know how you're meant to get rid of it though.
Hang on. I think it's like that. Yeah.
Okay.
Yeah, we're supposed to get rid of the P, I bet. So how do we get rid of P?
Well, you could do P is equal to F plus mg cos theta, but then you'd have an F. So
this F here, we could replace that with
mu R. You could replace it with mu R.
Mu R.
So then you would have mu mg sine theta minus mg cos theta on the top.
I'll say it again, sorry.
You'd have mu mg sine theta minus mg cos theta instead of P.
Yes, you could. Mu.
Wait, you wouldn't have. I think you wouldn't have mg cos theta because P is mu r plus mg cos theta. And then there's minus mg cos theta there already. So they would just.
So they just cancel each other out?
Yeah. So it would just be mu mg sine theta.
Mg sine theta. That's not. Oh. Yeah.
Just get mu equals mu.
Yeah. So the problem is we've got 3 variables but 2 equations. And that's why that's happening. Let's see. R equals mg cos theta. My mistake. It's the other way around. R is mg cos theta, and then this one is mg sine theta. I always get those mixed up.
Yeah, I don't know that either.
And so those are the other way around.
I think it's because when you draw like the triangle of the mg, it's the angle at the top that's theta, not the angle. And then explain it, but I think I know why it's cos.
Okay. Oh, no. Sorry. I just knocked over my T. So that one's sine. That one's cos. Okay. F equals mu r equals mu mg cos theta. F equals equals mu r and r. So F equals mu.
Then where did P minus mg sine theta come from?
Mg cos theta.
Oh yeah, but then you just get mu equals mu again.
So how did they get around that?
They did some weird. What?
Minus FKP. So F equals KP plus mg sine
For the
theta.
first one, they just left it as P equals something. That's not writing mu in terms of K and theta. Because they did like P equals mu mg cos theta. Isn't it meant to be like mu equals?
So they left it as P equals. Okay. Then the other one.
Confusing because they should have said express P there.
KP. So F mu mg cos theta. Mu mg cos theta. So they just replaced F with mu mg cos theta.
And they replaced P as well.
With what?
With the equation from the first one, where they did like P equals. They just replaced P in the second one with that. But I don't remember what it was. It's like mu mg cos theta minus mg sine theta, I think.
Oh, there's just so much. I never have enough space. Okay.
Yeah.
KP. They made K.
Replace P with that long equation.
So K mu. So these replaced P with what it was equal to?
Yeah.
So to eliminate it that way. Okay. So P equals, and instead of F, we use U mu mg cos theta plus
Minus O plus mg sine theta.
mg
I
sine.
think minus, but I'm not sure.
And so this KP
Yeah.
just becomes K, all of this.
Yeah. Is equal. I'm not sure. Yeah. Equal to mu mg cos theta.
It's equal to, minus mg cos theta. I'm subbing it into this one here. Okay. And so do you...
I don't know if you would well, you're meant to express mu, so you would have to expand it, I think, and then take out mu.
You could divide everything by mg.
You expand it and then bring all the mu terms to one side and then factorize out mu.
Yeah. Hang on.
That's the only way you would just like get mu by itself.
But you can mg, 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 mg.
Oh yeah, you can take out mg.
Okay. And so you want to expand the brackets and then make mu the subject?
Yeah. So mu k cos theta plus k sine theta.
Theta. Let's just... I'll bring the other one over.
Oh, minus u cos theta.
And so that was minus k.
Why is it minus k?
I'm bringing it to the other side. K sine theta.
Okay.
Minus cos theta. Okay.
And you just factorize out mu, so then you have k cos theta minus cos theta in the bracket.
So mu, and I'll just say it's equal to, and write the other side as like the fraction.
So minus k sine theta minus cos theta over k cos theta minus cos theta.
Minus
Cos theta,
cos theta. Okay.
that is mu.
Why did we make mu the subject?
Because it says express the coefficient of
Oh,
friction
yeah.
mu. Yeah.
In terms of k and theta.
They didn't
Okay.
do the first part, so
Well, no, we'll take.
instruction was confusing.
So we did do it.
Yeah. Like they didn't do it in the first, like when it's going upwards, they did P, so it's a bit confusing.
So they tidied it up a lot. Well, if you 1 plus k over 1 minus k tan theta, I suppose you could do that. But this is mu in terms of k and theta. So yeah, I'm happy there. Wow. All right. Any questions about that?
No.
Yeah. Okay. How about this thing?
I think you would use Suvat for this.
Okay.
Because you have to find time and distance. So don't know what S is. U is equal to U. V is equal to 0. I don't know what A is or T is.
U upwards along the line. Momentarily to rest. Let me see. A practical split. Okay. Speed u. So we're resolving in this direction. So that's u. What is a?
Not sure.
Would it be mg cos theta? Because it'll be acting against it.
No. Why would mg be the acceleration though?
So you have gravity, don't you?
Yeah.
So it's going this way at
So then
u.
it'd just be g. Then.
So g is straight down, isn't it?
Oh yeah. Okay, that's true.
And it'll be mg, wouldn't it?
Yeah. The force would be mg. Yeah. I don't understand the acceleration part. Why would acceleration be acting against it?
Well, friction will be acting against it.
Yeah.
And gravity will also be acting against it.
Do you mean weight by gravity?
Say it again, sorry?
Do you mean weight or gravity?
Like weight is like mass times gravity. Like
yeah.
mg.
Mg, yeah.
Let's just resolve the forces like normal.
Okay.
So you've got R.
F. Mg.
Okay.
So R minus mg cos theta.
R minus.
If you R minus mg cos theta is equal to MA. and then u minus, wait, is that the, yeah, okay. U minus f minus mg sine theta is equal to ma.
So this one here is going in this direction, is it? Like resolving in that direction?
No, it's
Sorry.
the other, because it's r.
That's this direction?
Yeah.
So in that case, I believe MA would be 0 because it's not actually changing.
Yeah, that's true. That's not actually changing.
So that one, MA will be 0 in that direction.
It's equal to mg cos theta.
Okay. In that direction. Let's see. So this direction is going up the plane, is it?
Yeah.
Okay. What do we do next?
Maybe like try and find a, like rearrange to find a.
Okay.
So it would just be divided by m.
I'm just thinking. We're acting against friction, aren't we? And it's moving up. So I think we've reached like F max.
Yeah. So F equals mu r.
So I think F equals mu r.
So you could substitute mu mg cos theta instead of F.
Into which one? This one down here?
Yeah.
And so instead of F, we can write
mu mg cos theta.
G cos theta. Okay.
And then you could divide through by m to find what a is.
Okay.
So you'd have u over m minus mu g cos theta minus g sine theta is equal to a.
Whew. Okay, that's our A.
So now you know what a is. So you can find s and t now.
Yeah. Let's just see. A equals it doesn't get any. Okay, so what would we sub this into?
You could do v squared equals u squared plus 2as to find s. So that's just 0 equals u squared.
Yeah. Yeah.
Plus 2 times that.
That's right. A.
Yeah.
And S.
That doesn't really help.
We could try time first, like V equals U plus AT.
Yeah. See where is equal to u plus at.
Hang on, U. We don't need U here, I don't think.
I don't think u is a force, so I'm not sure why.
Yeah, we don't need U. So maybe that makes things a bit simpler.
So it'd just be f plus mg sine theta then.
Plus sine theta, something like
No, but the friction wouldn't be negative, so you can't take out minus g. You can only take out g because the friction won't be in the negative direction. If you resolve the other way, obviously.
You check this, man. Here I am trying to make my life easy. Okay.
Yeah, that's right.
Okay.
It needs to be minus. Wait, shouldn't it be plus sine theta if they're both going down that way down the plane?
You made me.
Because like f and mg sine theta is like the same direction,
But it was minus f.
but that's because we resolved that way with the u. But since u isn't a force, then you could just do f plus mg sine theta because it makes life easier. If you
So it'd be equal to minus ma.
would it be? I don't know.
Like you would just be swapping.
I don't know if I don't know if it'd be minus ma. Then you can just leave it then.
Yeah, it'd be the same thing.
Okay.
You can absolutely take out minus g, but anyway.
Okay.
So what is v? V is 0.
V is 0. U is u. A is g minus mu cos theta minus sine theta. And t is t.
T. Okay.
Well, is equal to that.
Let's see. Find the time taken. So we want time.
Do you want what t is somehow?
Just bring it to the other side and divide through.
Yeah.
So we bring that over. It becomes negative.
You would have u over t is equal to minus g or something.
So we want t by itself.
Yeah. You want u over minus g.
Yeah.
Okay.
The whole thing. Minus g minus u cos theta minus sine theta. And this will all become positive.
Yeah.
So we might as well just make that all positive. So that's t in terms of u and theta. In terms of u, mu, theta, and g. So that must be for the distance. So how do we now get s?
Well, you know what t is, so you could do like s equals ut plus half at squared. That would be long.
S
Or
equals
literally any other equation that helps find s. But
t squared. Might be.
you could also do v squared equals v squared. Oh wait, no, that didn't help before.
I think it will be easier now though. Well, we'll see. V squared equals u squared plus 2as. So it's still 0 equals, isn't it?
0 equals u squared. Well, we know what a is already, so.
So a is yeah, and we have to make
Subject.
s the subject, yeah.
So that would just be u squared over minus 2a.
Let me see. Is it minus u squared?
Minus u squared.
Because you'd have
Yeah,
to.
you could do minus u squared over 2a, yeah. You could do that as well.
So minus u squared over, and then it's just the whole thing.
Yeah.
2 g minus mu cos theta minus sine theta.
Yeah.
And let's just check. So that is u g mu cos theta, u g mu and theta. Yeah. Okay. Number 2.
relation must be satisfied.
And I'll just bring over this bit forward. Okay, so we need that. Okay, any idea about part 2?
So, not really.
Let's see. So we have S and T. 1 second.
Must be satisfied by mu and theta. It doesn't really say anything about S and T.
Okay, just in case.
Moving back down the plane, wouldn't S be negative?
Depends how far down it goes. If it goes past its starting point, I suppose.
So S would just be getting smaller.
Yeah, has to be decreasing. Relation must be satisfied with mu and theta. If it starts moving back down the plane. So what would happen to mu?
Mu would like change direction.
Yeah.
The direction of friction would change if it's going to move back down. I don't know what really.
I don't really get what they mean, but let's just see. So, if it starts rolling down?
Yeah.
So do they mean just like find? Okay. So now friction is this way?
Yeah.
I don't know. So now it's rolling down this way. Okay. What do you get there?
What's the force called that's going down?
Maybe there's no force.
Yeah, because it's rolling by itself.
Yeah, it's just...
So it's just minus F minus mg sine theta.
Minus F minus mg sine theta
is equal to MA.
Seems alright. What relation would you have a mu if it has to move back down? So
maybe because it wants mu, you can do F, like substitute mu R instead of F.
So mu, this one, is it? Instead of F?
Yeah.
Okay.
And then the vertical one, that's just R equals mg cos theta is equal to, yeah, that's it.
Sorry, I was just simplifying that one. Vertically?
If you resolve vertically, it's just R equals mg cos theta.
R equals mg cos theta. Okay. And
I'm not really sure what to do next.
I'm not really sure either. Like what do they want, or I don't know. That's part 1. Looks alright. Part 2. So they cancelled out the m's. For movement, g sine theta.
Oh, the acceleration has to be greater than 0 to like make it move. Okay.
Oh, okay. So A is greater than 0, therefore this will be greater than 0?
Yeah.
It's mu g.
Couldn't you just times by minus 1? But then you'd have minus A, wouldn't you? So it's useless. Okay. So minus mu g cos theta is greater than g sine theta. Like
Yeah.
g sine theta. And then you could divide through by g. Just get rid of it.
Oh yeah, so mu g. So let's just get rid of it now. Cos theta is greater than sine theta.
You could divide through by cos theta, because then you
Okay.
minus mu is greater than tan theta. Wouldn't that be the answer?
And they just multiply it. Oh, hang on.
Minus 1 and reverse the inequality, I think.
Okay, so we swap
Yeah, so mu is less
those.
than
Yeah.
tan
Tan theta.
is
Is it
greater.
tan theta is less than mu?
No, tan theta is greater than mu.
Greater than mu. Oh, because you have to swap it.
Yeah, you have to reverse the
All right.
inequality. Hey,
Okay. And number 3.
travel back to its starting point. Okay, and the speed. So you want the time when s is 0, basically.
Okay.
So you don't really know what u is, so I think you'd have to make like s equal to, I don't know, but you don't know what u is, do you? Like, does it stop and start again?
I
Or
think it would have to, wouldn't it?
okay, because then u would just be 0, right?
So u is 0, I think, and because last time v was 0, now u is 0.
Okay, so then you could find. Wait, no. Mm, I don't really know.
Assuming that condition is satisfied, that tan theta is greater than mu.
Oh, so you need to find t and v. And you know what a is, you know what s is.
Okay. Yes, we do. So t is that thing over there.
Yeah, and you know what a is as well. So you just need to find v and t.
V is v.
Since you know u is 0, can't you find t? Because you just need, but then you have 0 over something, which I'm not sure if that works.
I think. Do we need a quadratic then? Because to get two values, like, so one would be the initial launching point, so time is 0. That's when it's at that point. But when it returns, what do we have? V squared equals u squared plus 2as. At plus a half at squared. Which one is that? S?
Yeah, s equals 8. No, it's ut plus half at squared, yeah.
T squared. I think that one might work.
Okay.
Or would it? Maybe not.
Wouldn't s be 0?
S is 0. S is 0.
Yeah, because it's
I think,
traveled
well,
back to the starting point. So s is 0 at the starting point.
so it kind of depends on how we go about this then.
Oh, s is not 0. S is minus u squared over 2g, like that whole equation, but not minus, because when it's going up the plane, it's minus. So when it's going down, it should be the other sign. So it should be positive, I think.
Yeah, so we're actually saying the starting point is at the
Yeah, so
top.
s. But the distance traveled is also u squared over 2g.
Yeah, but you're right about the sign, I think.
Yeah. So you could use that in some equation to find out like what t is or something.
So that's S V.
You know A as well. We worked it out before. I'm guessing it's the same, but just change sign again.
So A
Just change
was.
the sign. So UG mu g cos theta plus g sine theta.
So it's that down there.
But you could divide by g. Yeah, it's basically that. I don't know. Do you have to include the g? Can't you just divide?
You need the G.
Okay.
We just factorized out the G here, didn't we? I could factorize it out.
Yeah. So you basically know everything except t.
And so, how do we get it then?
Use one of the equations, like s equals ut plus half at squared.
So we have A, S, and U. Yeah, V squared equals U squared.
Yeah, or that one.
So S. Oh, sorry, I don't
You
know.
can't use that. Oh no, you can. You can. Never mind. So v squared is equal to 0 plus 2as, which I honestly.
Okay, so
So v squared is equal. No, v is equal to the square root of those things timed, multiplied.
what do we got? Do they say anything?
U squared g mu cos theta minus sine theta over that whole.
Yeah, and it might simplify a bit because you have.
Oh, you have g and 2g, so you could
Yeah.
cancel out g's.
So U squared. It's 2 times that, so this 2 cancels as well. So I think
You'd have u squared over mu cos theta minus sine theta, and then over minus mu cos theta.
I shouldn't write U squared because we're just multiplying those two. So U squared.
So why can't you write u squared? Oh, you shouldn't just write that. Okay.
Mu cos theta minus sine theta. And that's over. We cancelled out the 2 and the G. Minus mu cos theta minus sine theta. That's close with the signs. It's nearly 1, but it's not. Okay, so that's V. And V. Oh, I don't even care about the sign. Plus, minus. Okay. And what else did we have to find? The time?
Yeah.
So
I don't.
we could do S equals UT plus a half AT squared for that one.
Yeah. So you just have the whole S thing and then half times a t squared. U is just 0, so the ut part just gets.
Yeah, so it's just, yeah, U squared over 2G minus mu cos theta minus sine theta equals a half times A times T squared. Okay, so a half G
Cos theta minus sine theta. T squared.
T squared. And so, yeah, go on.
And then You want to divide by half g mu cos theta minus sine theta somehow.
Yeah. And so I'll just square root it as well in one go.
Yeah.
So that would be...
So that would be 2u squared.
I think it would be like... I think just put u squared on the top and then everything else on the bottom. So 2.5 can cancel each other out. It's all right. That'll simplify.
Because it's when you divide by g mu cos theta minus sine theta over 2, then you have to flip it. So it gets 2u squared.
Over 2g.
Oh, yeah. Okay. 2's cancel each other out. Right. And then g squared minus mu cos squared theta plus sine squared theta.
Oh, I'm leaving that one for the philosophers. I'm just doing this. Cos theta minus sine theta. That's it. And the time would be positive. Yeah, that's it. Okay. And that's number 3. And they've got a bunch of crazy.
Right.
Yeah. It's a shame. I thought it might simplify. They simplified it a bit by changing the signs. So instead of 3 minus signs and 1 positive, there's 1 minus and 3 positive. Same thing. Any questions with that?
No.
Okay. Okay. How about this?
Oh, this way. Okay. Oh, I've done this question before. It's hell.
Is it worth doing then?
Like, I've started it. We haven't like finished it, but no one knew what to do. So it's so hard.
Well, you're doing it.
We did it in school once, but like no one knew what to do because it was like just so confusing and so difficult.
We can do them from the book if you want.
Huh?
Or we can do this. If
No, I did it a year ago. I don't remember.
Okay.
But I just remember it was really hard.
Okay. A straight groove. Okay. It's connected alternately of sections of length 2b and b. So this one is rough. This one is smooth. Okay. So it's like B2B, B2B, something like that.
Yeah.
The coefficient of friction between the rough parts as mu. On length B. Okay. So it looks something like that.
Mm-hmm.
I think it was said it was theta. I think we have basically a particle here and here.
Mm-hmm.
They're connected by something. This is like, it's basically quarters.
Kind of, yeah. But the rod's only length B. It's not that long.
Oh, okay. The first is at the top, and the second is of a smooth section. Okay. Yeah. I don't know. So I'll just pick that.
Shouldn't it be on the other B because it's like at the top? One's at the top.
Oh, it's at the top, is it?
Yeah. Find the condition to be satisfied by mu. Wouldn't it be mu is less than F over R if they're moving?
Okay.
Is that
For identical particles, slide in the groove. The coefficient of friction is mu. The groove's forward. and it's released. Find the condition to be satisfied by mu if the particles start to move. So mu is less than F over R. Seems good. Yeah, I think that's fine.
The speed at which the low particle has reached. Okay. I'm not really sure how you'd find the speed. I'm guessing it would be Suvat again.
Okay.
So S is well, it starts at B already. So S is 3B.
Actually, I just thought this one you could just say it's equal to it, because if it's moving, then it's reached F max, hasn't it?
Oh yeah.
So maybe you could say like less than or equal to.
Point of sliding, that's an F is equal to mu R.
So yeah, I suppose less than or equal to for that thing, but if it is moving, okay. What is next?
So yeah, Suvat.
Okay.
Since the lower particle is already at B, would S be 3B?
Say it again, sorry.
Since the lower particle is already at B, would it be would S be equal to 3B for when it's at the bottom of the second smooth section?
I don't really get it. Like, would you have to model the whole thing as one big particle?
I don't know. That's why I said this question is like so hard. No one gets it.
Because it's not a particle, it's two particles, you know? Like
Yeah, but they're attached, so is it like one particle?
Something like that or something?
But they're attached though, so yeah, but still have separate everything.
It's a light rod, is it?
Yeah.
So I'm just kind of like, okay, if you did it like that, I don't know.
I think they'd have separate force diagrams. Tension, there'd be tension in the rod.
So tension
and friction. Would friction be in the same direction as wait, yeah. For that one it's the opposite, but for that one it's the same.
And then you have friction going. I don't even know how to diagram that one. Okay. So we could do like F minus R.
F minus R.
Like you could resolve.
Oh, resolve. Would that help though?
I mean, I think you have to. Or okay, how would you do a Suvat wise?
I'm not sure if S would be 3B or 4B because the lower particle is already at B, so wouldn't distance traveled be 3B?
Do you have to do the two separately or something? Like for one of them, S is 3B, and for the other S is no, it'd be 3B for both, wouldn't it?
No, for the top one it would be it would be 3B for both of them.
Okay.
So S is 3B. U is, I think it's 0 because they're released.
I think so.
We don't know what we is, but we want to know what we is. A. sum of f equals MA. So you would have to find A,
Yeah.
and we don't really care what T is.
Yeah.
So should probably resolve. So to find A, which one are you resolving? I feel like you'd have to resolve them separately because their frictions are in different directions.
Are they?
Oh no, they're not. Never mind. But would you have to resolve them separately, or could you do it together?
We could try together.
Okay, so would that just be like 2r minus 2mg cos theta is equal to 0? But I'll just give you r is equal to mg cos theta once you've simplified.
R equals mg cos theta.
And then t minus f plus mg sine theta.
Resolving. Sorry, say it again. T.
Wait, are the tensions in different directions for both of them?
Yeah.
Okay, so I'm doing the particle at the bottom.
Yeah, we're not going to get this finished.
Yeah, it's so hard. C minus f minus, wait, no, plus mg sine theta.
Let's see. Find the speed. So I think eventually you would have to do like v squared equals u squared
Yeah,
plus 2as.
yeah. Do it. Yeah, it's just hard.
Yeah.
Okay.
You'd have to work out v.
Yeah, that's what you want at the end. Is what we use. So
And yeah, that would be 0. S, that's all right. And then A would be the that you would rearrange for.
yeah, okay, that's fine. I get how to do it.
Yeah. And that was the last of it. Yeah, how was that for you, Amogha?
Good.
So any topic in particular you want to do next time?
I'll just send questions again.
Okay. Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.